Hello and welcome. I'm Andreas. I work as a trainer and consultant primarily for C++. And I'm also the creator of C++ Insights. And this is also the tool I like to talk about in this series. So I like to continue to talk about lambdas and what they can do. Here is a one-line example of lambda, and it demonstrates another power we can create with lambdas. Say we have on the left, that's a function pointer. It's a definition of a function pointer returning an integer, taking an int in a char, and we gave it the name fp for function pointer. And now I can initialize this function pointer with a lambda. And I can do this only with a captureless lambda. Okay, this is the key here. A captureless lambda can decay to a function pointer. If I transform this, then you see a lot of things we already know. It's a class, it has a call operator. We see an implicit cast here, nothing to do with lambdas. We call this another episode because our jar here gets promoted to an int. And then you see something special here. This is a conversion operator, and it may be a little bit hard to read, but essentially that conversion operator says that it is convertible to a function pointer returning an integer, taking an int in a char. And it calls another method, underline invoke, which is marked in the private here, and we can see it's also static, and it takes, or it has the same signature as our call operator. It returns an integer, it takes an int in a char, and internally it repeats our lambda's body. This invoke trick is the key how we can assign a lambda to a function pointer. Because if we look down here, then we can see here my lambda is created. I'm calling conversion operator on it, and what gets returned gets converted into my function pointer signature. So this is helpful if you deal with legacy APIs. So let's say you have an API that expects a function pointer, but you don't want to write a function because it's like this here. It's a simple one-liner thing. So then you can also use a lambda and pass it like it is a function pointer. So this is another side what lambdas can do for us and how they behave internally. This is the invoke function, which the compiler also creates for us. And just to be clear here, this is available since C++11. I was only in C++14 from a different example. That's it for today. Stay tuned for the next episode. Bye bye.